last section in this introduction to matrices unit here, we're going to be learning about two things that are just kind of some key vocab, key concepts for working with matrices, and that is inverses and determinants. And we are going to be looking specifically at them with a 2 by 2 matrix. You can find inverses and determinants of more than just 2 by 2 matrices, but we're just going to be looking at 2 by 2s for the purpose of this unit. So, two matrices, matrix A and matrix B, are inverses of each other if their product, AB or BA, are what are called identity matrices, or matrices. If they are an identity matrix. So an identity matrix is a square matrix. So all matrices are rectangles, but not all of them are squares. A square matrix would be one that is like 2 by 2, 3 by 3, or it could be like 4 by 4, 5 by 5. Essentially, it just needs to have the same number of columns as rows. And so, or the same number of rows as columns would be a better way to say that. So an identity matrix is a square matrix, but not just any square matrix, but one that specifically has ones along the diagonal. So as you can see in this 2 by 2 identity, we've got ones diagonally, and in this 3 we have ones diagonally. And then all of the other terms should be a 0 for it to be an identity. So everything else except for the ones in this diagonal need to be 0 if this is going to be an identity. So that's what an identity matrix looks like. So two matrices are inverses of each other if their product in both directions, AB and BA, are identity matrices. So we are going to be looking at these two matrices, matrix A and matrix B, and we are going to be verifying that they are inverses. So this tells you that they are inverses. On your practice, you're going to need to discover whether two matrices are inverses or not. This is how you can find out if they are or are not. We have to take the product of the matrix A times matrix B, and then matrix B times matrix A. And what we should expect to find, since matrix A is a 2 by 2, and matrix B is also a 2 by 2, when we multiply these together, they do have the same number of columns in the first matrix times the number of columns in the second matrix. We should expect to get a 2 by 2 matrix, which if it's an inverse, it will be this 2 by 2 matrix. We should expect that after we do all of our multiplication, that we will get the answer is this matrix 1, 0, 0, 1. That's what we should expect to find at the end if they are in fact inverses. So let's find out. We would be taking, in this case, AB would be this matrix 4, 1, 3, 1, and multiplying it times B, so that would be 1, negative 3, 4. And so as we are multiplying these together, we will start with the 4 from matrix A, because we'll be multiplying the first the first row from matrix A times the column from matrix B. So this will be the 4 times this 1 first. Then I would do the 1 from matrix A times this negative 1 from matrix B. I apologize. We're multiplying the row from matrix A times the column from matrix B. So the next number I would do is this negative 3 from matrix B. So I would do plus 1 times negative 3. Okay. So that will give me the first entry for this matrix. Then for the next one, I would do again this first row from matrix A, but this time it's going to be times the second column from matrix B. So we would do again this 4, but this time times the negative 1. So 4 times negative 1, And then we'll take the 1 from matrix A times this 4 from matrix B. So plus 1 times 4. Okay, and then for the one down here, we will be using the second row for matrix A times these columns from matrix B. And so we will start with 3 from matrix A times this 1 from matrix B. So 3 times 1. And then the 1 from matrix A times this negative 3 from matrix B. So plus 1 times negative 3. Okay. And finally, we will now be doing the second row from matrix A times the second column from matrix B. So we would start with this 3 times negative 1. And finally, the 1 times 4. Okay, so now we can go ahead and multiply through. Let's see, 4 times 1 will give me 4. And then the 1 times negative 3 would give me a negative 3. So 4 minus 3. For the next entry, 4 times negative 1 is negative 4. And the 1 times 4 is a positive 4. So I'll put plus 4. And going down, 3 times 1 would give me 3. 1 times negative 3 would give me a minus 3, or negative 3. And then for the last entry, 3 times negative 1 is negative 3. And 1 times 4 is 4, so I will put plus 4 since it's a positive. And ultimately, we get 4 minus 3, which is 1. There we go. Negative 4 plus 4, which is 0. 3 minus 3, which is 0. And negative 3 plus 4, which is 1. Okay, so that is an identity matrix. It's a 2 by 2 matrix where we have 1s diagonally and then 0s everywhere else. And so this would seem to suggest that this is an identity, that these matrices are inverses of each other, because we do get this identity matrix. To make sure, we should check that B times A also gives me the identity matrix. So when we multiply, instead of A times B, if we multiply B times A, we should also get to this identity matrix. So B is the matrix 1, negative 3, 4. And then A is the matrix 4, 1, 3, 1. So let's make sure that if we kind of switch the order of things and multiply them together, that we still get this identity matrix. So we are going to be starting by doing the first row from matrix B times the first column of matrix A. So this is going to look like the 1 times 4 here. The 1 from B times the 4 times A. The 1 times 4. Then I would take this negative 1 from B times the 3 times A. So this would be plus negative 1 times 3. Okay, for the next one over, I will now be doing this first row times the second column from A. So we will start with the 1 times 1 here. Looks like I didn't quite finish out that parenthesis. So we have 1 times 1 here. And then I will do the negative 1 times this 1 from B and A. So plus negative 1 times 1. Okay. For the next entry, I need to now do the second row from B times the first column of A, and then we'll do the second column later. So to start with, we will do this negative 3 times 4. And then 4 times 3. And finally, now we're going to be doing this second row times the second column. And so we would have this negative 3 times 1. And the 4 times this one. Okay, so now we can go through and do our multiplication. We've got 1 times 4, which is 4. And negative 1 times 3 would be minus 3. Then I have 1 times 1, which is 1. Negative 1 times 1 would be minus 1. Going down, negative 3 times 4 would be negative 12. 4 times 3 would be positive 12, so plus 12. And finally, negative 3 times 1 is negative 3. And 4 times 1 would be a plus 4. Okay, so we can go through to get our final product here and do this addition and subtraction here. 4 minus 3 is 1. 1 minus 1 is 0. Negative 12 plus 12 is 0. Negative 3 plus 4 is 1. And so we do, again, get this identity matrix. So since both of these products, AB and BA, result in identity matrices, we can confirm that, yes, these are inverses of each other. Okay, so we would say, yes, these are inverses. So on your practice, you're going to be looking at a couple of different pairs of matrices, and you're going to need to determine if they are inverses or if they are not. If they are inverses, you're going to get these identity matrices when you multiply them. If you get anything else, then they are not inverses. All right, I'm going to end the video there, and we'll do a part 2 for the bottom part.